Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we're going to learn algebra. Today is our lesson number 61. We are in the process of learning how to multiply algebraic expression. In the first 20 days, we learn how to evaluate algebraic expressions, then we learn how to add and subtract them. Right now we are in the process of learning how to multiply them, and then we'll learn how to divide algebraic expressions before we get into the nitty-gritty of linear equations and the word problems. Day number 61. Let's see what we have for today. We are asked to multiply together. Multiply together these two expressions, negative 3/2 a and 6a squared minus 5b squared plus 12ab. Well, first thing first, we have to understand and we have to realize that these are expressions here. This is one expression. It has three terms in it. 6a squared, positive 6a squared is the first term. Negative 5b squared is the second term. Positive 12ab is the third term. It has three terms. This, on the other hand, this is an expression with only one term in it. The term being negative 3/2 a. And our job is to multiply algebraic expressions. Let's do it then. This is no different. I'm going to give you a simple example so we can see it. This is no different than multiplying something like this. If somebody asks you to multiply p times x plus y plus z, this is the exact same thing. In this scenario, your p is negative 3/2 a, and your x is 6a squared, our y is negative 5b squared, and our z is 12ab. Exact same thing, exact same idea. You have to distribute the p times x plus p times y plus p times z. That's all. Let me give you a numerical example. If you're asked to multiply 5 times 3 plus 7 plus 5, well, 3 plus 7 is 10, 10 plus 5 is 15. So this quantity is basically 15 times 5, which is 75. So if you open the parentheses, we will get exactly that. We will distribute 5. So in this scenario, our p is 5. Our x is 3, our y is 7, and our z is 5. And we're going to distribute this 5 here. Let's change this thing so we don't keep calling both of them 5, so we don't get confused. Let's make this a 4, in which case this is 14, in which case this will be 70. So now we have 14 5s. 3 plus 7 is 10, 10 plus 4 is 14, 14 times 5 is going to be 70. 14 times 5 is going to be 17. How do we know that? Because 14 times 10 is 140, so 14 times 5 should be half as much. Or even simpler, just take 5 away from the answer we had before, which was 75. So 5 times 3, that gives us 15. 5 times plus 5 times 7, that's going to give us 35. And then 5 times 4, that's going to give us our 20. I want you to understand and appreciate that these are some numbers, these are some quantities. They are written in this manner because we do not know the values of the a's and b's. But if we knew the values of a's and b's, we could plug them in and evaluate their values, numerical values, which is what we did in the first 20 days. But because we do not know what a's and b's are, we have to multiply them like that way. But it is no different, the principle is the same. Now when we add these three numbers up, we better get 70. 14 times 5. 15 plus 35. 15 plus 35 is same as 40 plus 10, which is 50. 50 plus 20 is 70. Voila, you see? 70. So that's what we have to do now. We have to distribute negative 3/2 a throughout this entire expression. Let's do that then. We're going to distribute. This is how we speak in the language of the algebra. If somebody asks you what are you about to do, you tell them that we're going to distribute negative 3/2 a throughout this expression. Or another way of saying the same thing is, we're going to multiply this expression by negative 3/2 a. Same exact thing. So we have our negative 3/2 a, which we're going to need 3 times. Negative 3/2 a and negative 3/2 a. We're going to need it 3 times. First time we're going to multiply it by 6a squared plus, you put a plus sign here, plus negative 3/2 a times the second quantity, which is minus 5b squared, again plus negative 3/2 a and the third quantity, third term. That's it. Here we do not need to put a plus here because everybody understands that if there is no sign, it's a plus, it's a positive. Had it been a negative 12ab, we would have put a negative here. But this guy has a negative in front of it. So negative times positive is going to give us negative eventually, but we will worry about it when we get to it. So now we get going. So negative 3/2 a times 6a squared is this right here. Negative times positive, there's a positive here. Negative times positive is negative. 3/2 times 6, 3/2 times 6, 3/2 times 6, and a times a squared. A times a squared. That's the first part. Let's move on to the second part. I already put a plus here without actually knowing whether or not it's going to turn out plus. Besides, it's going to need a different color. Negative times negative is positive, so it is plus. And then we have 3/2 times 5, and then a times b squared. Now, because there is no multiplication sign here between 5 and a, it does not make any difference. This is same as this. There is no difference. As I already explained to you several times, there are several different ways of expressing 5 times a. You can simply say 5a, or you can say 5 times a, or you can put 5 and a in the parentheses, or you can put 5 in the parentheses, a, leave, or you can put a 5 in the parentheses and leave a out, or you can put 5 in the parentheses and a in the parentheses. These are all exact same ideas. There is no difference. 1, 2, 3, 4, 5. There are 5 different ways of saying the same bloody thing. It's not different. I run into many a times where students just freak out. They think that these parentheses are some secret codes, mysterious language, and they're very apprehensive about putting parentheses or if they leave them out. The parentheses are for convenience. Purely for convenience, to keep the things separate so that your eyes can see from far away that these two quantities are being multiplied. You understand? For example, let me give you a simple example. If I tell you 7 plus 3 plus 9 plus 9 minus 17 plus 34 plus 24, but the bloody thing goes on and on and on forever. Now if I wanted to, I could put the parentheses around it, so it would be easy for me to see from far away that it begins here and ends there. That's all. That's all it is. It serves no other purpose. If I leave the parentheses out, it's not going to change anything. It's still the same quantity. Do you understand? They're just purely for convenience. The parentheses are purely for convenience. Anyway, let's finish it up then. So now we have to figure, we haven't done the third one. We did the first one, we did the second one, now we have to do the third one. Let's put it in a green marker so we can keep everything separate. So now we are doing this green one here, right here. So negative times positive is going to be negative, and then 3/2 times a, this a right here, times that a, times b. Now we have to simplify. That's it, we're done. It's just a matter of simplification and we'll have our answer. So, negative, this half will cancel out with this 6, because this is 6 over 1, you see? This is 3/2 times 6, which is same as 3/2 times 6 over 1, and you multiply that and you get a 9. So it's negative 9. A times a is a cubed. Oh, that takes care of that part. Let's move on to the blue one. See here, this 2 will not cancel out with this 5. This is 5, which is same as 5 over 1. So you get 3 times 5 is 15 over 2. Positive 15 over 2. And AB squared. AB squared. So that takes care of that part. Let's move on to the green one, the last term. We must have left something out. I left out the bloody 2. You see? This 2 here, we have 12 AB. I just put down AB, I forgot the 12. technically it is 12 AB, but since I forgot the 12, I'm going to insert it here. It's not going to change anything. 3 times 2 times 12 is still same as 12 times 3 times 2 times 2. I forgot what I said. 3 times 2 times 12 is same as 12 times 3 times 2. In the multiplication and in addition, orders do not matter. The orders of the numbers only matter when you are subtracting or dividing. Of course, if you're subtracting, there's a big difference between 10 minus 3 and 3 minus 10. Of course, it matters which orders you say things into. But if I were adding, it doesn't matter whether I say 3 plus 10 or 10 plus 3 is the same bloody thing. Same thing with multiplication. Whether I say 3 times 10 or 10 times 3, it doesn't matter. It only matters in the case of division. But of course, it matters in the case of division because 10 times 3 is an entirely different thing than 10 over 3, 10 divided by 3 is an entirely different quantity than 3 divided by 10. So only when we're subtracting and dividing, the orders of the numbers matter, but addition and multiplication, the orders don't matter. So since I left out 2 inadvertently, I inserted the 2 at the bottom, at the end, right here. This 2 is right here. I had forgotten it. So now, it turns out that there is something we can do here. This 2 will cancel out with this 12, making it a 6. And we'll end up with 3 times 6, which is 18. Let's continue in the green marker that we were doing. Minus 18. And then here we have A, and here we have A. A times A is A squared times B. Voila. That's our answer. That's our final answer. Let me verify it, make sure I got the same answer in my notes. Negative 9A cubed plus 15 over 2 AB squared and negative 18A squared B. Now where does this 18 come from? Why is this 18? This 18 is 3 halves 12. 3 halves 12. Where can I do it so you can see it? I'm going to squeeze it right up here so you can see it. 3 halves, right here. 3 halves, where is it? Right here. This 3 halves times 12. Oh, this is getting quite nasty. This box that you see here, 3 halves, forget about the negative sign for the time being. This negative times, this 3 halves times 12 turns out to be 18. How would you convince somebody that 3 halves of 12, 3 halves times 12, 3 halves times 12, or you can say, I'm going to read this thing. It says 3 halves of 12. This is how it's read, 3 halves of 12. How would you convince somebody that 3 halves of 12 is 18? How would you convince somebody cogently? Well, 3 halves of 12, we know half of 12 is 6 and we have 3 of them, which is why the bloody thing is called 3 halves. Half of 12 is 6, therefore 3 of those will make 18. Hence, 18. That's all. That was the answer for the problem. I'm going to call it a day. It turned out to be a very long video even though we only did one problem. Let's call it a day. I'll see you again tomorrow on day number 62. Okay? Bye.